Hello everyone, happy Friday. Today we are going to talk about the properties of logarithms. So there's 5 different properties I'm going to talk about. I would highly recommend writing these down in your notebook because these properties we're going to deal with for the rest of the chapter. So you're going to want to know these, okay? First thing I want to note with all of these properties that the bases always have to be the same. So you always have to have the same base. All right, so our first property looks like this. So log base b of x plus log base b of y equals log base b of x times y. So these are equivalent expressions. Again, notice the bases are the same. So these properties only work when the bases are all the same. And the key thing here is when you are really adding 2 different logarithms together, what you're really doing is multiplying their arguments together. So let's say I had, log base 5 of 8 plus log base 5 of 6, let's say. Notice my bases are the same, so my property applies. And since we're really adding these 2 things together, what we're really doing is multiplying their arguments together. So another way I can write this expression is as log base 5, that doesn't change, and then multiplying these together, 6 times 8 gives us 48. So these would be equivalent expressions. They mean the same thing. All right, our next property then looks like this. So we have log base b of x minus log base b of y, and that equals log base b of x divided by y. So same thing. Let's say I have log base 6 of, 9 minus log base 6 of 7. Since my bases are the same, the property applies. And when we have subtraction within the logs, what we're really doing is dividing the arguments. So again, it'll still be log base 6. And then divide the arguments. I'm just going to write it as a fraction as 9 divided by 7. If I could have cleaned that up, so it was like 9 divided by 3, I could have cleaned that up and called it 3. But seeing as I can't do anything to simplify 9 over 7, I would just leave it like that. All right. My next property looks like this. So when we have log base b of x to the n, another thing I can do with that exponent is I can really bring it out front and multiply it by the log. So for example, let's say I have log base log base 2 of, let's say, 5 to the third. Another thing I can do with this is move that exponent out front and times it by the whole expression. So another way I could write this as 3, because that is moving out to the front, times log base 2 of 5. And this works in reverse too. So let's say I had 4 times log base 3 of 6. I'm just pulling these numbers out of my butt. Another thing I could do is move that exponent back and write this as log base 3 of 6 to the 4th. This next one is super similar. So this is saying log base b of the nth root of x. Another way you can write that is 1 over n times log base b of x. But keep in mind, let's do another example. Another way I can write, let's say, a square root. Another way I can write a square root is with an exponent of 1/2. And again, we know we can write exponents as a multiplier out in front. So another way we could write that is 1/2 times log base 7 of x. So these two are very closely related because we know we can write radicals as a fractional exponent. And again, exponents go in front. My last one is log base b of b equals 1. Whenever your base and your argument are the same, that whole expression always equals 1. So for example, let's say I have log of 100, log base 100 of 100. That equals 1. Log base 7 of 7 equals 1. And if you think about this, this actually makes a lot of sense. If I put these into exponential form and do my log roll, we would get 100 to the power of 1 equals 100, which we obviously know to be true. All right, so there are the 5 properties of logs that I would like you to know. Again, I hope you wrote those down. I may or may not, I have not decided yet, create another video showing you guys where these come from and how they're derived. That would be optional, but if you're interested in how these rules came applied, that would be there. Okay. All right, so I just have kind of one example for you today, 3 parts. So your homework tonight, they're going to give you what I'm calling these keys, and they're going to ask you to approximate the following values. Okay. So I'm going to look at this key first. So let's say I gave you log base 2 of 3. And I asked you to figure out what that equals. The past couple of days, what we would have done is we know it equals something, but we don't know what. So I would set it to equal to x. We would then get it in exponential form. So I would do a log roll and get 2 to the x equals 3. And then right now, all we know is to get the same bases and then set their exponents equal. At our disposals right now, we and our mathematical abilities do not know how to get 2 and 3 to be the same base. Okay, so I've kind of provided you that information. So if I get this in exponential form, this is saying 2 to the power of 1.585 equals 3. And I can type this into my calculator to prove it. So 2 to the power of 1.585 equals pretty dang close to 3. Okay, so this is what this information is telling you. And same thing over here. 2 to the power of 2.322 is going to equal approximately 5. Okay, and again, we can't make that the same basis. So we can't solve for what that would be by ourselves. Okay. All right. So we are going to use these 2 pieces of information. And there's also one more piece of information that we know that they didn't give us. We also know what log base 2 of 2 equals. So when the base and the argument are the same, looking at my property, we know that equals 1 every single time. 2 to the power of 1 equals 2. Okay. All right, so now for the actual problems. What we are going to do is we are going to use the numbers 2. We're going to use our arguments. We're going to use 2, 3, and 5. And any combination we want as many times as we want. And then multiplication and division. And we kind of have to puzzle together how we could get 15. So using 2, 3, and 5, multiplication and division, how can we get the number 15? And hopefully you guys are coming up with, well, 3 times 5 is another way to get 15. So I'm just going to rewrite 15 as 3 times 5. All right, now here's where those properties are going to come into play. I look at my properties. We have multiplication within our argument. So we're going to kind of go backwards here. So multiplication within my argument means that I'm really adding those 2 logs together. So we're going to take this 1 log and we are going to expand it now into 2. okay, using that property. So again, we know when there's multiplication within the argument, we know that we are really adding those two logs together. So I've expanded that into two separate logs now. And now from here, we just get to do a simple substitution. I know log base 2 of 3 is really, they gave it to me, 1.585. And I know log base 2 of 5 is really 2.322. And now they're simple numbers. We can definitely deal with them. I'm just going to use my calculator and add those together. So 1.585 plus 2.322, we get 3.907. And when you're doing your homework tonight, I don't want you guys to round it all. Give all of the decimal points. I think in your homework, even I asked you to give 4 decimal places, okay? So don't round it all. All right, let's go ahead and look at this next one. So we have log base 2 of 8. And again, I want to use 2s and 3s and 5s and multiplication and division and try to come up with 8. And I'm actually going to show this one 2 different ways. So the first way I'm going to show it is I can get 8 by 2 times 2 times 2. So that'll give me 4 times 2 again gives me 8. And again, using that same property, I know when I have multiplication within my argument, I can really split that up. I can expand that into multiple logarithms that are added together. So in this case, since we have 3 things being multiplied together, we're going to have 3 things added together when we separate it. So this first one, I will have log base 2 of 2 plus log base 2 of this 2 plus our last one, log base 2 of 2 again. And again, it just comes down to a simple substitution. I know log base 2 of 2 is really 1. So I'm going to substitute 1 in for all of these. And last time I checked, 1 plus 1 plus 1 is really 3. I said I would show this one another way. So another way I can write 2 times 2 times 2 is really 2 cubed. And look at our properties, this one right here. We know exponents really go out in front and multiply it to that log. So now that I have this exponent, I know that it's going to go out in front and be multiplied by the log. And now again, our substitution, I know log base 2 of 2 is really 1. Notice that sign did not change there. It started with multiplication, so it also ended with multiplication. And again, 3 times 1 is just 3. So notice 2 kind of different methods there, but we got the same exact answer. All right, let's do one more. So this last one, we have log base 2 of 9 divided by 5. So again, using 2s and 3s and 5s in multiplication and division, I need to figure out another way I can write 9 divided by 5. Again, there's a couple different ways I can do this. I think I'm going to write 9 as 3 squared. And I like 5s, so I'm going to keep 5 as 5. All right, first thing that sticks out to me is that division sign. And again, we know when we have division with the argument, I can really split that up into 2 separate logs using subtraction. The first thing I'm going to do is split that up using subtraction. So we have log base 2 of 3 squared, and that division we really know means subtraction. So minus log base 2 of 5. And again, I see an exponent. I know exponents really can go out in front and be a multiplier. And then again, our simple substitutions. I know log base 2 of 3 is really 1.585. And then I know log base 205 is really 2.322. And now all I'm going to do is type this in. And we get 0.848. And again, I want all of the decimal places, no rounding. All right. Again, I think I'm going to make another video to show where the properties came from. So if you're interested in that, watch out for that. And have a good weekend, you guys.